Welcome to the championship final of Computer Science and IT Exam Strategy. Listen, you have exactly 90 minutes to glory when you finally sit down in that exam hall. The clock starts, the silence hits, and it's just you and the paper. Today, we are building your ultimate bulletproof game plan for absolute exam victory. We are cracking the code on the Cambridge syllabus, specifically Section 8.2 on test data. And let me tell you, whether you are tackling syllabus code 0417, 0478, 2210, 9618, or the main one we are deeply dissecting today, 9626, this topic, understanding normal, extreme, and abnormal data, is an absolutely critical area. It appears in almost every single exam series. It is literally unavoidable. Now, to understand how to win, we need to look at how students usually lose. Notice the two completely contrasting approaches we typically see. On one side, we have Alex. Alex overloads his answer with raw computer science facts, basically pouring every single thing he ever memorized onto the page, hoping something sticks. But there is absolutely no analytical depth. None. Then on the other side, we have Sam. Sam is panicking, rushing against the clock, and completely missing the specific requirements of the command words in the question prompt. Look at the sea of red pen marks covering both of their answers. It's a bloodbath of lost marks. Today, we are going to fix that. We're going to take those red marks and transform them into green check marks. We have a packed and highly strategic agenda for our session today. First, we are going to map out the core principles of test data. Second, we'll dive into the method mark strategy to get you maximizing your points even if you make a calculation error. Third, we'll unpack the critical analysis framework for problem solving. And fourth, we'll cover top examiner warnings straight from the principal examiner reports. Let's start right off the bat with a major blinking red examiner alert. This is a direct quote from the people who actually grade your papers. They say students are throwing away high marks simply because they are confusing basic terminology. Examiners are literally begging candidates to be precise. Let me give you an example. When our student Alex wrote his exam, he put down normal data is good data and extreme data is big data. You know what the examiner gave him? 0. Not a single point. Why? Because the vocabulary isn't professional, it lacks any kind of technical precision, and frankly, it shows a fundamental misunderstanding of the rigorous Cambridge standard. The entire theoretical architecture of this syllabus rests heavily on precise definitions. It's like building a house. If your foundation is made of sand, the whole thing comes crashing down. If you don't define your terms accurately before analyzing a system, you lose the examiner's confidence in the very first sentence. You have to speak their language. So let's look at our first core principle, defining test data types. The theoretical architecture of this syllabus rests heavily on precise definitions, causal relationships, and cross-topic integration. Now, to truly master this, top students structure their definitions using a specific technique called the PEEL framework. That stands for point, evidence, explanation, and link. You don't just state facts. You make a point, back it up with evidence, provide an explanation of how it works technically, and link it back to the overall functionality of the system. But hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, let's get back to it and see exactly how this PEEL framework applies to our very first definition. Let's apply this foundation to normal data. Normal data represents the standard, everyday inputs the system is expected to handle smoothly. It's the bread and butter of the system. If we use the PEEL framework, here's how a top-tier answer looks. Point. Normal data is data within the expected valid range. Evidence. For example, if a system accepts test scores between 0 and 100, entering a score of 50 is using normal data. Explanation. This is because 50 is a standard expected value that the system's logic is designed to process without triggering any error handlers. Link. Therefore, testing with normal data proves that the system's core functionality works correctly for the majority of standard user interactions. Boom! Do you see how much better that is than Alex just saying normal data is regular data? You are actively demonstrating to the examiner that you understand the concept theoretically, practically, and fully in context. You're showing them you know exactly what the system is supposed to do under normal conditions. Next up, we have extreme data. Now, this is designed to push the system to its absolute, accepted outer limits. And this brilliantly illustrates where candidates like Sam completely fall down. Remember Sam, he rushed the question and said extreme data is data that is too big. No, absolutely incorrect. Extreme data is still acceptable data. It is valid, but it sits right on the absolute boundary of what is allowed. If we go back to our test score system that accepts values from 0 to 100, the extreme data points are exactly 0 and exactly 100. They are 100% valid. The system must accept them. But they are at the very edge of the validation rules.
Testing extreme data verifies that the boundary logic, things like the greater than or equal to operators in the underlying code, are actually functioning correctly, which prevents those nasty edge case crashes. It proves the system knows exactly where the cliff edge is without falling off.
And finally, we arrive at abnormal data. This refers to erroneous information that your system must be smart enough to safely reject. This is data that is way outside the acceptable boundaries, or it's of a completely wrong data type altogether. Imagine entering 105 into our test score system, or even better, entering the word banana instead of a number. The system shouldn't just freak out and crash. It should catch the error and present a user-friendly error message. Testing with abnormal data proves the overall robustness of the system's validation routines. So let's recap quickly. You have normal for the safe middle, extreme for the absolute edges, and abnormal for the wild outside. Memorize that precise distinction right now, because confusing them is exactly what the principal examiner report called out as the absolute #1 mistake students make year after year. Now that we've firmly defined our terms, let's transition to our second major topic, the technical methodology, and how this builds directly into the method mark strategy, where marks are awarded for your procedural framework. But wait, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCSE, to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. All right, let's get into the mechanics of how you actually pick up these marks. We call this the Computer Science Success Blueprint. Listen closely, because this is crucial. Even if your final calculation or conclusion has a slight error, showing your systematic process guarantees you pick up the majority of the available points. Examiners love process. Systematic processing follows this exact 5-step standardized sequence. Step 1. Identify the key elements of the scenario. Ask yourself, what are the validation rules actually given in the prompt? Step 2. Apply relevant principles. Which data types are demanded by the command word? Step 3. Execute analysis with clear working. You literally need to write down exactly what specific data you would input. Step 4. Verify results. State clearly what the system should do when it gets that input. And Step 5. Present in format. If the question asks for a test table, for the love of everything, draw a test table. Don't write a long, rambling paragraph if the command word implies a structured table. This structured, disciplined approach is exactly what separates an A-star candidate from a C candidate. Let's put this into practice with a quick interactive workshop. Imagine a 60-second visual countdown timer on your screen right now. Your first challenge is a data scan. I want you to mentally picture a complex prompt about a remote weather station recording temperatures. The text says the sensors operate between -50 and +50 degrees Celsius. Your data interpretation skills here are critical because top-performing students extract from the text to draw highly evidence-based conclusions. You cannot just invent data out of thin air. You must extract the exact parameters given in the specific examination scenario. So what's your test data? If you're scanning correctly, you'd pull out -50, 0, and +50, and maybe the word snow for your abnormal data test. Interpreting the relationship between the physical hardware constraints and the software validation rules is exactly where you secure those highly elusive evaluation marks that push you to the top tier. This brings us seamlessly to Section 3, critical analysis, and building an ironclad problem-solving strategy for those complex, highly unfamiliar contexts they love to throw at you. Superficial breadth won't work here. Examiners are hunting for analytical depth. Let's do challenge number 2. We are going to find the flaw. This brilliantly illustrates the deconstruct, solve, evaluate framework, guiding you step by step from identifying information all the way to making justified recommendations. I'm going to give you a flawed sample paragraph from a student, and I want you to spot the sentence that loses the marks. The scenario is an age verification system that requires users to be 18 or older. The student writes, to test the system, I will input 25 as normal data, 18 as extreme data, and 17 as abnormal data. This will ensure the system works. Okay, did you catch the flaw? Where did they drop the ball? The fatal flaw is in step 5 of our blueprint, making justified recommendations or explanations. The student listed the data perfectly, but they completely failed to state the expected outcome for each input. Without explicitly stating that 25 should be accepted, 18 should be accepted, and 17 should trigger a rejection error message, the answer is totally incomplete. Always check your answers for reasonableness and completeness against this 5-step framework. Moving to challenge 3, speed writing.
If a higher-order question asks for comparative analysis, you must explicitly identify both similarities and differences using comparative connectives and concrete evidence. Imagine you have a 30-second timer counting down right now, and you need to write one perfect Peel paragraph comparing extreme and abnormal test data. How do you do it? You use comparative connectives like whereas, conversely, or on the other hand. Here is what a perfect top-mark response sounds like. Both extreme and abnormal data are utilized to rigorously test the system's validation boundaries to ensure robustness. However, whereas extreme data represents valid inputs precisely at the acceptable limits and should be successfully processed by the system, abnormal data is fundamentally invalid and is specifically inputted to verify that the system successfully catches and rejects the error without crashing. That paragraph right there? That is pure, unadulterated examiner gold. It shows high-level comparison, it uses concrete evidence, and it proves deep, undeniable understanding. Finally, we are entering the end game. Let's look at insider secrets, top examiner warnings, because here is the brutal truth. Even with the perfect framework, there are major traps you must avoid to secure full marks. To guarantee those top marks, you need a solid foundation, like decoding those tricky command words, applying the Peel framework consistently, and managing your time allocation perfectly for every single mark available. But applying these helps you avoid the top 3 devastating mistakes examiners see constantly: confusing cause and effect, forgetting to check format and presentation, and providing answers completely lacking context specificity. Let's unpack these traps. Mistake 1. Confusing cause and effect. Students often write, "The system crashed because the user inputted abnormal data." No, the system crashed because the programmer failed to write adequate error handling routines for abnormal data. The input is just the trigger. The poor code is the actual cause. Mistake 2. Forgetting to check format. If the exam asks for a test plan table and you write a beautiful essay, you score 0, period. Mistake 3. Answers lacking context specificity. Listen, if the question is about a self-driving car's sensor inputs, and your test data examples talk about a library book checkout system because that's what you memorized from the textbook, you will lose the marks. You absolutely must use the specific nouns and verbs provided in the exam scenario. So, how do we keep this all straight when the pressure is on? I have a quick and clever memory hack for you to avoid these terminology mix-ups in the absolute stress of the exam room. Create your own mnemonic using the first letters of normal, extreme, and abnormal data. NEA, normal, extreme, abnormal. Think of it as never enter aimlessly. You must always have a strategic plan for your test data before your pen even touches the paper. Never enter an answer aimlessly. We've reached 100% on our progress bar today. You now have the complete answering system. Remember the 3 rules that guarantee top marks. Decode the command word, apply the PEL framework, and manage your time. As you review your notes today, I want to leave you with this final provocative thought. How will you confidently adapt this systematic process the next time you face a completely unfamiliar scenario on test day? When they throw a brand new technology at you that you've never even studied, remember that the core principles never change. Normal is the middle, extreme is the edge, abnormal is the outside. Trust the process. Now, listen closely. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.